video we are going to talk about beta function, so beta and gamma functions. So first, what is beta function? So definitions. The definite integral of 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, where this is very important, guys. This is very important. So this condition is very important, guys. So it's defined as a beta function and it is denoted by beta of m comma n. So this m comma n can be changed. So you will see in upcoming sessions. So this is very important, guys. So this is very important. This is denoted as a beta function. So just remember this. Just pause the video and remember it, and then turn on the. So let me explain the other things. So this is a beta function, and then these integrals is also known as the first Eulerian integral, but this is of course not useful, but let you know, just a general knowledge. And this is a symmetric property that I mentioned before. This m comma n and n comma m can be interchanged. That's why beta function is called symmetric functions, and it has a symmetric property. So let me prove it. So let take x is equal to 1 minus y, and then 1 minus x is equal to y. So if this is as usual, so now differentiate it, you get dx is equal to minus dy. So let's substitute in this equation and just solve. You used to get it. Just a variable is different, so it doesn't matter. But here if you see, in place of m, n is there. In place of m, n is there. So this proves that it can be interchangeable. And now different forms of beta functions. So first form is this. So beta of is equal to 0 to infinite. So there are three forms in beta function. All the three forms are very important. So beta of m comma n is equal to integral of 0 to infinite x to the power m minus 1 by 1 plus x to the power m plus 1 dx. So just remember it, and this is proof. This is as usual not that much necessary. If you are interested, just pause the video and go through it. And now beta function in terms of trigonometric function, this is more used, most used cases, and this can be modified into an useful case. This is an useful case. So this is mostly used a form of beta functions. So just remember this is more important than the previous one which we see here. This is more important, guys. Just give some importance to this in remembering. And now come to the gamma functions. So definition of gamma function. What is gamma function? So the integral 0 to infinite. So now just compare. What is beta function? Beta function start with 0 to 1, but gamma function start with 0 to infinite, and e to the power minus x into x to the power n minus 1 dx, n is greater than 0. So this is also an important. It's defined as a gamma function with the parameters n, and it's denoted by this symbol, guys. This symbol inside that, and this is a representation of a gamma function. And now as said before, just as an equation, and now this integral is also known as Euler's integral of second kind. As usual, no needed, but it's a general knowledge. So this is important, just make a note of it. And now properties of gamma function. So gamma of 1 is equal to 1. How? You can see it here. This is the proof. And now gamma of n plus 1 is equal to n into gamma of m. Just remember this, guys. That's enough. Proof is not needed. If you are interested in proof, you are a max student, max branch, then it may be needed. So just pause the video and go through the proof. And now, and if n is an integer, this is very important, guys. Many of them make mistake in this is mostly used, and mostly mistakes are done here. So if n is if and only if greater than or equal to 1, then only this is applicable. But many used to do this, like if there is something 1 by 2 or something which is lesser than 1, they used to do this. This is absolutely wrong. So this is important conditions, just remember it. So this is the proof of that. And now this is somewhat important proof, sometimes may be asked in examinations. To prove that gamma of 1 by 2 is equal to root of pi. So first they are taking x is equal to y square and then differentiating, and then just they're solving it. By the way, they are also changing the limits, and now we know we get this. And now just change the variable to x in terms of y, so change everything uh, as x. So this is another thing, both are same, so just they are multiplying it and getting this, and now they are changing into a polar form and then solving it. So they're changing into polar form and then solving it, and at last, after solving everything, these are simple calculations, simple integration. Yeah, if you see this, it is self-explanatory, and if you see this, at last you get to know that gamma of 1 by 2 is equal to root of pi. So now relation between beta and gamma functions. So this is an important relation, you have to remember this also. So beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n, where m is greater than 0, n is greater than 0. This is very important. In this beta and gamma function, please make a note in conditions. So conditions are very important. Greater than 0, less than 0, equal to 1, like that. Conditions are very important in this chapter. So by definition, we know that gamma function is this. This is actually a proof of that. This is actually not needed. If you want, just go through it. This is the second part of proof, and this is third part. So this is actually not needed that much. If you are interested, you may go through it. And these are the particular it's like applications of that beta function which we saw before. And the important thing here is the examples. So first, find the value of integral 0 to 1 x to the power 7 1 minus x to the power 6 dx. So as we know, beta function is form of this, and now change this into this form. So you used to get 8 minus 1, 7 minus 1, so 8 and 7 or n and m respectively, or m and n respectively. So you know the relation between beta and gamma function. By using that, you used to get this, and you know that gamma function of anything which is greater than 1 is nothing but the n minus 1 factorial. So n is 8, so n minus 1 is 7, so 7 6 8 plus 1 15, so like that 14. And this is similar to that, you can go through it. And this is I said before, we know that this is another form of beta function. So by using it, we used to get this, and now at last we get this, and now we have to use the relation between beta and gamma functions to solve it. So by using it, we solved it, we got this, that's it. It's simple, super simple. And now, so this is somewhat little interesting. You get a sign, so cos is not there. So you should not say, or you should not think that this is not a form of beta function. So cos to the power 0 is there, so 1 minus 1 we have to cos to the power 0 is there. So by keeping cos to the power 0, we have to do this. So they took cos to the power 0 and they applied the formula which we seen before, that is nothing but the 1 by 2 beta into p plus 1 by 2 q plus 1 by 2. So p and q are respectively 5 and 0, somewhat like that. And then they got the answer. This is simple, and this is similar to that, sine is to the power 0, and this is also same, using the formula, getting, and this is the answer, simple. And now this is another tricky question. So there is no sine, there is no cos, it's a root of 10, not even tan, it's a root of 10. So now just change the tan into sine by cos, and now just simplify into sine into cos, something like that. So if you do that, you get sine to the power 1 by 2 and cos to the power minus 1 by 2. And now you can put the formula which we learned before, that's 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. So p and q are respectively 1 by 2, so 1 by 2 minus 1 by 2, and now you used to get the form. So as it is lesser than 1, you can uh, present the answer in this way, not to simplify it in any more. If they give the gamma of 1 by 4 is something something, then you can substitute here. Until that, this is enough. And now similarly, you have to change it into sine by cos and then solve it, used to get this as an answer. So it's super simple and self-explanatory. So let me go to the next questions. And this is the combinations of the both which we've seen before. So we know the answer of this is this, and this of the answer this, as we seen the both things before itself. So just they're multiplying it. If this question is given, you have to solve it by making tan as a sine by cos, and then putting as in the formula that we learned before. And now this is as same as like that, simply using the relation between these beta and gamma functions at last used to get the answer. This is simple. So that's it guys. So in second part we can see many questions in beta and gamma functions. Bye bye.